Hello, everyone. Nice seeing you here attending this talk. I'm not sure if it's going to work with my laptop, because I need a dongle to get it connected. Okay. Just a moment. While we are waiting for that one, I'm going to tell a little bit of a story. I had a lot of things preventing me to come to Romania to speak at this conference. It's all started with a short connection in Paris airport, where I basically landed at the airport gate right 1 minute before the gate was closed, because I had to go through passport control, because I didn't know before that Romania is not in Schengen. Then they lost my bag in France. And I only got my bag yesterday. But when I got to the airport to pick up my bag, there was a huge storm. And you know what happened? I got completely wet. This is very special talk because it took me a lot of, how do I say it even? A lot of work went into this talk to make it happen, right? Okay, so now it should probably work. Let me try it out. Okay, good. So our talk is about performance and performance with indexation in Magento. How many of you had indexation running, never stopping in production system? Okay, like 30% of the audience here. So this talk will be very helpful for you, and probably you'll get excited what's going on in the open source area. I'm kind of one of the developers who is closely involved with Maze.js, an open source distribution of Magento that tries to go into the direction of better performance, new innovations happening in the sphere. So first of all, I want to share with you a small thing that I'm Ukrainian. And for me, it's very important what's happening right now in my country. However, I not live in Ukraine for 10 years already, but I still keep it very close to my heart. So if you wish, here are some charities that support Ukraine. One of them is Ukrainian, Come Back Alive. And another one is a Dutch charity that I contribute to as well. So let's now start with a little bit of talk about me. You already learned that it was a problem to travel here for me. But you don't know another thing about me, that I'm very passionate about open source, and I really want to have open source succeed and bring it to the next level. So it's not just stays on the sidelines and the product itself goes in obscurity in future. I'm really good at optimizing performance of web applications. I do work not only with PHP. Recently, I had a customer where I had actually to optimize their Java application. So yeah, apparently I know a lot of languages now. Another thing, I'm grandparent of Magento. So I'm one of 5 core developers who started working on Magento back in 2007 in Kyiv, Ukraine. We had an office in a technical floor of a high-rise in Kyiv, where we had all the time problems when it was raining because the roof was leaking, and we were building a new, nice open source project that you now all enjoy. Another thing, I'm experienced in putting out fires in production, especially related to performance, because performance is always a problem for merchants, and merchants always think about performance when it bites them, right? So they never think about it during development process. They think, hey, we can optimize later, whatever, but then you have to rewrite a lot of stuff to make it more performant. So I basically deal a lot with such stuff. So let's talk a little bit about why indexation is actually important. So the first reason is that querying normalized data is very inconvenient from point of view of performance, right? We all know about the AAV structure, and in order to query it, you would have to do complex SQL selects in order to access some product attributes, right? Also, some data can only be stored normalized. But in order to query it fast, for specific store, for instance, right, you want to create a denormalized view, like a flat table, that you can do quick searches on. Another thing is we have also some expensive calculations, right? So customers can see different prices based on their customer group and so on. So this kind of calculations are impossible to do if you want to also filter by those values with standard normalized table structure. So you create an index for that. Another one is that you have full text search. Like if any one of you tells like full text search is not important, I think it's one of the most important tools in a web shop, because customers usually don't go through the menu, they start typing in a search box. So that's why indexation is very important, because it provides keywords association to the actual products in order to build this data. And you cannot query in a full stack search manner just regular product data in EAV table structures, right? So I think we can summarize that, okay, indexation is good. Anyone against indexation here? Okay, that's very nice. So what is actually offered in Magento by default? Like Magento has two distinct ways how you can store index data. The first one is actually enabled by default. It's called update on save. Anyone knows any drawbacks with that type of thing? Yeah, please. Correct. Do you know why? Yeah, so it's within a transaction of the product save operation. So it doesn't take into account changes from import-export as well, apart from actually slow save, because the import-export completely ignores all those events that are fired. It even disables indexation when it's running. Then it also prone to timeouts and deadlocks, because when you have multiple people edit the same product, you have a deadlock on the index table and you're screwed, right? So one of the shop managers actually will have a problem. Or in worst case scenario, when two customers buy the same product, you have a deadlock on a stock table, right? And then you have also another issue. But then you cannot resolve it between each other, because you cannot say, hey, you can buy, you cannot buy, right? Another offer from Magento is update by schedule. And this one is implemented with kind of materialized view, but it's not really a materialized view. It's kind of a way that PHP just creates a bunch of triggers on tables, and then these triggers actually append some data into changelog table, and then you have to read from it, you have to clean it up. So it's not really a materialized view. It's basically just a table, right, that you populate yourself from PHP. Materialized view do not exist in MySQL, so they're kind of things from Oracle. Also, another issue with the update by schedule is that you have now your database littered with these CL tables that are all over the place, that are always growing. You have to think about, hey, why my database is so huge? Then you look, hey, there is billion records somehow in CL table. Here's another. Oh, that's very interesting. I don't see it on my screen, but it's on your screen. Over there, there is a name of a table. So good luck reading that. I'm so sorry. So another thing is that writing triggers is hard. There is a very long story with mview in Magento 2, where it actually introduced a lot of issues. So let's take a look at 2.2 version of Magento. Anyone still running in 2.2 in production? No, no one. OK, that's good. Because Magento core team at that time didn't know how to use a kind of compare operator in MySQL. And in 2.2 version, it was the inverse condition. Like, if field is not modified, we're going to fill out your changelog table. If it's modified, we're not going to write anything. So, so basically, you have to decide yourself, OK, how you're going to do it. So there was this huge issue. One of the huge stores in New Zealand had downtime once in a while just because of that issue. So it's fixed now, but we have 2.4 now, right? And look, Magento thought, hey, our MView indexation is so slow, so we probably need to batch it because we have too much IDs coming in one single batch, right? So they implemented batching, but now like there's 2 more GitHub issues that are still open and that are confirmed, right? One of them is that asynchronous indexation breaks large stores. So kind of reminds me of something in 2.2, right? So it's kind of a pain point. And what I want to tell is that triggers are very hard to grasp if you are not testing them. And unfortunately, core team doesn't have any single test case that really tests if you insert something into the database, it gets inserted into the changelog, and then you can verify it. So there is no test like that. So now we have a situation like this that from time to time we have a huge error where some products are missing on MView because they're skipped because of the batching that they introduced. So yeah. But there is also, apart from this, known issues on GitHub, there's others not that so obvious. So the first one, that every single write that you do to product tables introduces another write to a changelog table. And if you have a lot of concurrent updates, you might also introduce another wait lock, or even sometimes deadlock if you have a lot of people editing products, even if it's not the same product, but because it's tables that inserts data after each other, if you don't have right transaction isolation levels on your MySQL server, you are going to be screwed. Another one, catalog staging, introduces even more database queries to those triggers, right? So it's now have to resolve this row ID to the actual entity ID in order to put into the changelog table. So you now have 2 queries per each update in a database table. And another thing that it's very dangerous if you don't know how to set up replication right with triggers. Because if you have like multi-origin replication where you have 2 servers, one goes live if another fails over, so you have live replication in both places, you can basically create infinite loop of trigger inserts, right? If you don't know how to properly specify that all those CL tables have to be actually ignored. So it's very easy to shoot yourself in the foot. So I would say triggers are quite bad. So the question is, like, can we do better? Actually, yes, right? Otherwise, I wouldn't give a talk here, right? Then I would say, okay, everybody go home, nothing to see here, right? So first of all, MySQL already have something that we can use, and almost every single store uses it in production for recovery from failure. It's called binary log. So if you think about it, like in AWS RDS, it's enabled by default. So every single Aurora or MySQL have binary logging enabled. Maybe you have to do some tricks to make it better to use this tool I'm going to talk about today. Another thing is that row-based replication is actually default since MySQL 8. So before, like, we had this statement-based replication that was very dangerous because statements are not independent, right? So they can change over time. Data in rows cannot change over time. So you better use row-based replication than statement-based replication. Another thing that experienced DevOps already use binary logging in order to run production systems, right? Because it's a good tool for recovery. If your database server crashes, you can manually walk through a bin log with special tools and restore manually lost orders or something that you saw like crashed your system. So you can inspect it, see, okay, this value has been inserted in this table because of that database crashed. So you can walk back some of the damage without resorting just to backups, right? So it's a very powerful tool. Another thing, actually, that is overlooked quite often, that it gives you complete access to changelog history of your database. So you can keep a binary log for some amount of time. You can like expire them after 10 days or whatever settings you use in production in order to not overgrow your file system. But basically, until binary lock expires, you can look every single change to a product, every single change to a category. You can see when it happened at what point of time. So it's a very good tool. So how I would usually do for the tools that I'm going to talk about here, for configuration, like if you just put in MySQL configuration, if you just put this small thing called logbin, right, it will automatically enable binary login with everything default paths of the file. So usually it's MySQL data directory. Then you would need to change, if you are not on MySQL 8, you need to change to raw format, because raw format is the safest one for replication, and it gives us the whole history of the data, not just statements, right? So it's a very nice tool. Another thing, it's binlock raw image. By default, like it's full, but I usually advise to change it to no blob. So for instance, if the text field with product description is modified, then you have to send it. But if it's not modified, binary lock won't contain the change. It will only contain a record if the record has been changed for text fields and for blobs. So that's why it's called no blob. Another one, it's expire log days. So after how many days you're going to expire your binary log, and the maximum size of the file for a binary log, after which it has to rotate. So then it can expire after some time, those files that are older. So this is a sample configuration. Another thing, I hate this color, you know, like on my screen it's very dark, here it's just white. So Linux has some problems. Oh yeah, I forgot to tell you, this morning I woke up and I realized my laptop doesn't boot up. So everything was preventing me from giving you a talk today, right? So I had to delete a new kernel that was automatically installed with the package manager. So it was like a few hours of my time this morning to fix my laptop. But it's very good for development. Believe me, Linux is the best. So in order to have binary tool working, about which I'm talking here, you need to have a user that has select, replication slave, and replication client permissions granted. And if you, for instance, already have MySQL user, which is majority of Magento shops with grant all, those permissions are already included. So you don't need to worry about it at all. So now let's talk about the tool that we have. It's called Mage's database changelog. It is written in Rust. So it's built as a static library. So you don't need to have any root permissions on your server at all. Like you just download binary, run it, specify MySQL connection settings, and it provides you the whole changelog you need for your information. Another thing, it's blazingly fast. And we will dive deep a little bit later into that thing. But because it's Rust, it's always blazingly fast, so because it's blazingly fast language. So how it works? So it's going to use connect as a replication client to MySQL. Then it's going to analyze the binary lock events, how they are read from MySQL to this client. It's going to map them into rows, so they're easier to process. Then it transforms those binary events into row changes. So every single row with a table is more usable for your further customizations that you like to do. Then those row changes are mapped into actual domain changes. So let's say you changed catalog product entity in table. You don't care about the table, you care which product attribute for which product has been changed. So this is the step of mapper to map the table binary lock event into the actual domain change that you care about for later use. Another one, there is aggregate. Aggregate does something that is not available in Magento with the standard triggers, because what it does, it collapses all of those singular events into one event where it groups every single change by attribute, by field, by whatever you want, so you can decide which indexers you're going to invoke. And we'll come back a little bit later today about it. Another thing, then Magento takes this log output with those aggregates and decides, do I need to run this MView with this product IDs or not? That's basically how it works. So another thing is nice that it's also easy to customize. So I spent quite a lot of time, and this Saturday, actually, I rewrote a huge part of the library related to customization. So this is very fresh info. It's also easy to create own mappers. So if you want to map some custom table to a specific domain event in Magento, you can do that. And in a couple of weeks, the simple skeletal application, so for you, like, you would just have to specify a mapper to the application, and it will automatically bootstrap everything else. So you can compile a new version of the application that will work quite fast. So here is an example of a mapper. First of all, the first line there indicates that it's zero-sized object. In Rust, I would call it struct. What does it mean zero size? It means it gets completely eliminated during compile time, so there is no memory allocated in order to create this object. And it means like every single code that you see here, for instance, for this trait, like for my awesome table mapper, this specific method basically gets inlined into binary. So it's one of the performance tricks of Rust itself. Then we have in this functionality, like we have this map event, and this map event, it receives an event that is actually a binary log event. Then it receives the current schema based on which this event is based. Then you can match event. For instance, in this example, I use update row. So the row has been updated in the table. Then I have a very nice tool I also wrote there. It's called field update, where I just specify, OK, I have a product ID and in this table, so I'm going to already assign it there. Then, if not awesome field has changed or super awesome field has changed, then I'm going to convert it into the changelog. If nothing changed, it will be just an empty event, and it will just go further away. And here, for instance, if we don't process this event, we just return back none. It means like nothing has to be done with the mapper result. Then you would do, again, the same thing with the mapper, but this time you would create a match based on your table name. And you would create this my awesome table mapper that we created before. You instantiate it and pass an event to it, and then you will map it to the product change. That's basically everything you need to do. Right? So you have all of those steps. And then you would just add it in future version of this tool with application, like with this method, with mapper, and everything what you need to do in order to create own application with the custom tables being managed by this changelog. So would you like to know some numbers, how it actually compares to the regular Magento triggers implementation? So I did run a load test, and I did create like something like 1,000. I requested 1,000 iterations, but it didn't do, actually, I think 100 iterations, but 100 products in each iteration. So this is a standard Magento with triggers, right? So we can see here, for instance, it did create 1,500 requests for HTTP API in order to update products. There is like 28 iterations dropped, so it didn't fit into the 10 minutes, so it had to drop like 28 requests because it didn't complete it on time. The average response time was like 352 milliseconds, and the minimal was 101, and medium is 383. So not bad numbers, right, for product API calls. So in total, like we generated 1,500, yeah, and it didn't finish, right? So it had a time limit of 10 minutes. It didn't finish 100 shard iterations within this time frame. And oh, sorry, it's too early to go into the next slide. I didn't talk about this number. So like we have 30 seconds in order to process all the changes that happened from this API load test. So I just created a bunch of changes for products, and then I invoked the standard MView update that Magento uses with triggers. Then what I did, I dropped all the triggers from tables, and I ran another load test, and then I invoked this changelog tool. So let's see. First of all, you can notice that there is a little bit more than 100 more requests has been processed within these 10 minutes. So it's already an indication that majority of the requests are faster, right? So we process them more. Another thing that there is less dropped iterations. The request waiting time, the average time is slower as well, right? And minimum is basically stays the same, like there is a small margin of error. But we can see that, yeah, the number of requests is very convincing, right? And here you can see that we have the total time of the indexation with this changelog approach is like 7.2 seconds. So it's more than 3 times faster than approach. But I didn't change indexer implementation at all. I just changed the way how indexation is invoked. So I check, OK, what is important for me to update the product category index? It's important if product went disabled or product became invisible, right, on the front end. Then I need to update an index. I don't care about all the other integer attributes. So that's where changelog helps, because it allows you to know which attribute has been updated for which products, and then you can actually decide which indexer you have to invoke. So here's how the output looks for this one. Like we have our attributes here grouped by ID, and then there is product IDs. Then we have metadata. The metadata is important because then you can just use this for the next time. So you read from that position in a bin log. You don't need to store anywhere your IDs. You just read it from bin log. You receive this JSON result, and you're a happy developer because you don't need to write changelog anywhere. You just invoke this tool and run reindexation. But that's not all. Like in that JSON, it doesn't show all the possible changes. First of all, if, for instance, you create a new product or delete a new product, you receive a notification about it. So, for instance, you remove a product that doesn't exist anymore. You can just invoke delete operation on your index. You don't need to reindex the whole index itself, right? So you can be more smart about it. Field and attributes. So field is basically a field on a product table or any other field named with the string. Then website all and website specific. So you can say some product has been assigned or unassigned from a website with the website all, or you can be more specific from which website the product was assigned or unassigned. So you can know which index table to update in future. So for now, like Magento doesn't support something like that. Magento only supports IDs of products. Then we have category all, the same situation as with website. Then we have links, and links it's actually group products, related products, cross-sells, everything goes over there. And then composite, it's for configurable, media gallery, and tier prices, right? So all of them later are going to be. So the roadmap for this project is actually to support category entity as well. So for now, it's only doing products. Also support staging functionality of Adobe Commerce by removing all of the magic from staging. What I've noticed actually by using this tool, I've noticed that Commerce has a bug where it puts data into CL tables for products that have not been yet live. So basically, you have a lot of records in CL that won't appear in indexes anymore. Here, we will add just another field, version of the content which has been changed. So you would be able to also decide, hey, do I want to put it into the index or want to create another index with a future preview or something like that. So you can play around with it. There is no limits. Also, I want to make sure that custom tables can be supported with configuration files. I want to backport this support for Magento 1 as well. So not only Magento 2 projects are going to be able to use it. And I want to make it like a plug and play, so you just do a composer dependency without caring where this binary application came from. It will just get installed by choosing the right architecture of your system. So if you want to get involved, you can join Main.js community. Like we do crazy stuff like that. You can follow the project itself on GitHub. Here is the URL. You can play around with the Rust files. There is some bright future ahead that this database changelog actually can be translated into security sphere as well in order to real-time monitor if someone inserts something malicious in your database and right away throw an alert or modify some rules to your web firewall. So you can play around with binary logging as much as you want. Like, it's so good. Another thing that I plan to do as well in Rust, I want to create data streams. So you would just use this changelog together with data streams to quickly access data from Magento EAV database without thinking about table structure. It will just assemble for you a very nice JSON object, which you can put into the indexation. So thank you very much. That was my talk. If you want to learn more about performance, you can join performance training I'm doing this July in Barcelona.
Thank you, Ivan. Let's give him a round of applause. Let me just get this straight. Is this open source available for any developer? You should have written that on the first stage.
Yes, there is a GitHub link.
OK, great. For the people who might want to give it a try, we recommend that because Ivan, as mentioned, he's one of the godfathers of Magento. It's really interesting to see how he
Godfather,
managed.
OK.
Godfather of Magento.
From grandparent, grandfather.
You've been blessed. Yeah. So as far as I see, the community hasn't changed. A lot of people who are still interested and engaged in the Magento community and developing products for the open source ecosystem. So yeah, thank you, Ivan, for everything. Questions for indexing? Sure. I have two. One more.
Sorry, I don't have anything to give away because I had so many issues with my luggage. You know? No. I'm not giving away because I stole it.
So you basically disable the indexer, the Magento indexer, and you let this tool that checks the MySQL binary log to update the data. It's confusing for me. I'm just trying to understand how it works.
Yeah, so I didn't disable the indexer. I disabled database triggers. So instead of triggers, I just use binary log and invoke manually mview update by IDs.
So it will still be the indexer that will actually have to run a cron job or whatever in the cron tab tables and runs every minute.
It's basically going to be the same indexer update views or something like that. I don't remember exactly the name of a cron job, but it will replace the cron job for the indexers that it supports.
Okay. You simply replace the way the change data is flagged. Basically.
Yes.
Okay, got it.
Thank you. One more question. OK, it was the same question. OK, one more.
Yeah, first of all, the question about if is this open source or not, it's useless because everything Ivan does is open source. But
Good. Good save.
Yeah. You owe me a hat, man. Yeah, now the real question, did you actually use this on a real-life project? And
so it's a proof of concept, but I'm planning to use it for one of the customers. It's actually why I'm working on it. And why it's open source, because one of the customers needs this tool in production. So.
And if you're allowed, are you going to publish some numbers after that?
Yeah.
OK, thanks.
Questions, anyone? OK, let me just finish off with a short joke. Hopefully this will work. So what have you learned from Ivan's presentation earlier? No, leave it on. I just want to add something more.
OK.
One short thing that you should have noticed on his presentation. It's about the joke I saw online. It's about a question to developers. What should a developer do before writing a new application or module or instance? Does anyone have an idea? The very first thing. Create a dark mode. It's the only presentation in dark mode. Come on, everyone. Let's give him a round of applause. Thank you.
Thank you very much.